What is wire EDM? Wire electrical discharge machining is a non-contact subtractive manufacturing process that uses an electrically charged thin wire with a dielectric fluid to cut a metal part into different shapes. The process produces small chips and precise cut lines by melting or vaporizing the material rather than cutting it. As a result, it can conveniently machine parts unsuitable for conventional machining techniques. However, the parts must be electrically conductive. How does wire EDM work? Machining a part using the process involves submerging the workpiece into a dielectric fluid, securing it with a machinist vise, and running the wire through it to produce sparks as it passes an electric current. In other words, the wire carries one side of the charge, and the workpiece, which must be a conductive material, carries the other side of the charge. When the two get close, a hot electric charge jumps the gap and melts tiny pieces of the metal away. The electric spark is the cutting tool to cut the material in the desired shape. Additionally, the wire EDM process involves deionized water to control the process and flush away tiny particles removed. Components of a wire EDM machine. The machine comprises several parts that work together to give a material the desired shape. Below are the components of the machine. 1. CNC tools. The CNC tools control the entire operation of the wire EDM machining process. Controlling the entire operations include being in control of the sequencing of the wire path and being able to manage the cutting process automatically. Note, the CNC tool's sophistication determines the error level and the machining time. 2. Power supply. The power supply unit is the component that delivers pulses from 100 volts to 300 volts to the wire electrode and the workpiece. Furthermore, it controls the frequency and the strength of the electrical charges that pass through the wire electrode to interact with the workpiece. It is necessary to use a highly developed power supply unit to deliver the necessary quality and type of charges during wire EDM machining. 3. Wire. The wire serves as the electrode to create the electrical discharge. The shape and thickness of the workpiece directly influence the wire's diameter. Typically, one can use wires with diameters ranging from 0.05 to 0.25 millimeters. The main types of wires used include brass wires. Brass is the most common EDM wire material because of its excellent conductive properties. It is an alloy of copper and zinc, and the higher the zinc content, the faster the wire cuts. However, there should be a balance because when the zinc content is over 40%, this decreases the corrosion rate of the brass wire. Zinc-coated wires. As the name implies, you obtain it by applying a coating of pure zinc or zinc oxide on the wire surface. Manufacturers use zinc-coated wires because it improves the machining speed. Diffusion annealed wires. The diffusion annealing process helps to create wires with higher zinc content, more than the 40% zinc. It involves coating wires with layers of pure zinc. These wires are ideal for mass production and can machine many materials. How to choose the right wire. To choose the right EDM wire material for your project, consider the following: tensile strength, fracture resistance, conductivity, vaporization temperature, hardness. 4. Dielectric medium. The wire cut EDM process must be carried out in a tank filled with dielectric fluid. This liquid prevents the tiny particles from the workpiece from getting attached to the wire electrode. The most common medium is deionized water, which cools the process and gives the workpiece a good surface finish. 5. Electrodes. The electrodes in the machine are the wire, cathode, and the workpiece, anode. The servo motor controls the wire electrode, ensuring it does not come in contact with the workpiece at any point during the wire EDM cutting process. Materials a wire EDM machine can cut. Wire EDM machines can create complicated shapes and patterns on a workpiece. Additionally, they can machine most materials that can conduct electricity, even the tough and delicate. Common shapes and materials you can cut with the machine include aluminum. Aluminum has excellent thermal and electrical conductivity properties. However, aluminum is naturally soft and can be challenging to cut with the process, as it may result in a gummy buildup after machining. Titanium wire EDM cutting is perfect for titanium, because the process can withstand the stickiness of this alloy and break up lengthy chips. However, you need deionized water as the dielectric medium to help control heat generation during machining. Steel is a very strong metal. As a result, many manufacturers favor using a wire EDM machine over a CNC machine. However, the material generates a lot of heat, so one needs to take the necessary precautions. Brass machine because it has high tensile strength. However, the cutting speed should be slow because it is a soft metal. Graphite. It may be difficult to cut graphite using conventional cutting tools, but the wire EDM process is appropriate because the wire is sharp, preventing particle pullout. Differences between EDM wire cutting and conventional EDM. The wire cut EDM process is an improvement on conventional EDM. Their mode of operation is similar. However, they have significant differences. Below is a few differences between both machining process. As stated above, the electrode used in wire EDM cutting is a thin heated wire. In contrast, conventional EDM uses highly conductive metals like graphite or copper electrodes to produce electrical charges. The electrodes are in different shapes and sizes, which affects their smoothness. For example, a round electrode produces the smoothest surface, then a square, triangle, and diamond. When the electrode is inserted into the workpiece, it forms a mold, leaving a negative impression of its shape. Speed of machining. The electrodes of conventional EDM must come in different shapes. As a result, manufacturers must create and shape them before the machining process, and this takes time. In contrast, the wire EDM machine is ready to use as soon as the wire is in position. This makes it appropriate for applications that must need to be completed quickly. Accuracy wire EDM machining makes use of wire as the electrode. As a result, they have better accuracy than conventional EDM. For example, the wire electrode allows them to cut at a thickness of about 0.004 inches. Due to their accuracy, they become better suited for machining parts with complex shapes and designs, unlike the conventional EDM, which is more suitable for more rigid cuts. Applications wire EDM machining is versatile and can cut ferrous and non-ferrous metals, so many industries use it. Also, size and shape do not limit its use because it can machine both long parts and extremely small ones. However, conventional EDM can handle harder and thicker materials because the thickness of the wire electrode in a wire EDM machine affects its use. Pros and cons of wire EDM machining. Pros of wire EDM. It makes precise and accurate cuts, eliminating the need for further processing and finishing of the workpiece. The process is suitable for creating complex designs and shapes that are otherwise challenging to produce using traditional CNC machining. It is applicable in machining small parts and for cutting highly detailed items that would otherwise be too delicate for other machining options. Wire EDM machining is ideal for fragile materials and cannot withstand the stress of machining. With just one stage of processing, the machine cuts materials leaving no burrs or distortion. The machining process cuts continuously without interruptions. Even if the wire breaks when cutting, the process continues immediately. It is only compatible with materials that conduct electricity. An oxide layer may develop on the cut surface of some materials, such as aluminum. Therefore, this could necessitate additional finishing, which raises the cost. It has a high initial investment and maintenance cost. Applications of wire electrical discharge machining. Automotive industry. The parts in the automotive industry come in complex shapes and sizes and are mostly hard. As a result, the industry favors using wire EDM machines because the process does not rely on mechanical forces and the wire electrode does not need to be stronger than the workpiece. The process applies to making holes and cavities to customize automotive car parts like bumpers, dashboards, car doors, and many more. Medical industry wire EDM machines produce complex parts with a high level of accuracy for use in all medical fields, including optometry and dentistry. Also, metals that work well with wire EDM services are frequently used to manufacture medical equipment. Since the wire's diameter determines the cut size, the wire EDM machine adds tiny features to parts like dental implants and syringe components without endangering their structural integrity. Aerospace industry wire EDM cutting produces parts with tight tolerances and is the go-to machining process for aerospace part manufacturers. This process, alongside the water jet cutting process, is especially used for parts that cannot withstand the high temperature and stress associated with traditional cutting tools. Parts in the aerospace industry need to have an excellent surface finish and be precise and accurate. Manufacturers use the Wire EDM process for years to make engines, turbine blades, landing gear parts, and many more. Conclusion: Wire EDM is a versatile and precise machining process that can be used to create complex shapes and geometries. It is often used in the aerospace and medical industries, where parts need to meet tight tolerances. Wire EDM can also be used to create prototypes or one-off parts. In this article, we hope that you now have a better understanding of Wire EDM